Hi, everyone. My name is Ofer Mendelevitch from Vectara, and today we're going to talk about measuring hallucinations in healthcare RAG. A little bit about myself. I had developer relations for Vectara, and one of the interesting things about my background is that I started using large language models in 2019 when GPT was in version 2. So I got quite a bit of knowledge about the space, and I've been really amazed seeing how it progressed since then. Now let's jump in. Um, we all know that the LLM world has really revolutionized everything. And I do believe what's stated on the slide, which is that in 5 years, every application we use, whether it's an enterprise application or a consumer application, every piece of knowledge we acquire and every device we'll use will have a generative AI interface enabling it. We will interact with devices and applications in a completely different way. Now, if you think about healthcare, here's some examples I picked up of use cases that I think would be quite useful in healthcare for large language models. So, for example, one of my favorite use cases is to generate post-visit summaries to reduce physician burnout. We all know that physicians spend an enormous amount of time um, at the end of their day looking at what they talked about with patients and creating these summaries. And it takes a lot of effort from them. And we can definitely automate this with large language models. Another interesting use case is the ability to ask questions about a patient based on their medical records and physician notes. One that I like too is to be able to make recommendations based on your care plan and generate that for the physician to be able to look at and come up with some suggestions in case they need that. There's other things like generate consent forms and discharge summaries, which are very good in terms of creating more efficiencies. And generally, patient education. Patients really like to ask questions and get answers about conditions that they have or medications that they take. So those are some good use cases. Now, one of the issues that I'm sure many of you have heard about is that LLMs actually hallucinate. And what does that mean? It means that they sometimes generate answers that are incorrect. Let me give you one of my favorite examples. If you ask ChatGPT 3.5 today, if Will Smith ever hit anyone, well, this is what it says. You can see it says, there's no public record or evidence of Will Smith having been physically assaulted or hit anyone, et cetera, et cetera. But we all know what really happened, which is this. So this is one example of how LLMs hallucinate. Um, and it is especially a problem in the context of healthcare because we cannot have LLMs generate the wrong response if it relates to our health. Um, so one way to address hallucinations is with this concept of RAG. Again, RAG stands for Retrieval Augmented Generation, which is a methodology that helps LLM focus on the facts and provide more accurate responses. So at a really, really high level, how this works is you take the user query, and usually you just present it to your large language model here, and you get a response. But with RAG, what happens is you take your own custom data set and you ask the LLM to answer the user query in the context of some facts that are being retrieved from your data. This is very useful for question answering, for chatbots or copilots. And it helps reduce hallucination because you essentially ask the LLM, don't rely on your own incomplete data set that you trained on maybe last year, but instead base your response based on these facts that I'm giving you. So how does this work? This is probably the busiest slide I'm going to have here for my presentation, but bear with me on this. This shows the flows of generating a RAG pipeline if you want to do it yourself. This is all the steps. So first you take your data. It might sit in a data warehouse or some other data store here. It could be in an enterprise application like Jira or Notion. It could be in S3 or on a local folder. Um, then there is a step of extracting the text from the original data source, and chunking, which is the idea of if the text is really long, let's say you have a 100-page PDF document, you want to split the text into subsegments. Sometimes it's a sentence or two or something like that. And then you take these chunks, which are more smaller pieces of text, and you run them through what's called an embedding model. This embedding model, and again, there's every box here. I have a couple of providers that provide this service, so you can learn from that. But these embedding models essentially turn the text into a representation as a vector of numbers. That's what these vector databases that people talk about are all about. You store this vector in a vector store or vector database, and there's a few mentioned here, but there's many more these days that are available. And you store a little chunk of text in a text storage database nearby, and then this is what you need to do when you ingest data. Now, when you run a user query, so the user asks some question, let's say, what is metformin or something like that. You embed the query of the question, create another vector, and then you use the vector store to retrieve the most relevant pieces of text that you ingested earlier out of the whole retrieval engine here. You get those facts that I have shown earlier. You construct a special prompt for the LLM, essentially saying, given these facts, can you respond to this question of what is metformin? And then the LLM does its work. It could be GPT-4, it could be Cohere, Anthropic, etc., and sends the response back. On the way, you might also have something that validates the response and removes bias and protects against things you don't want it to say, and you show it back to the end user. So this is where kind of the flow of everything you have to do yourself. And as you can see, it gets pretty complicated. Like each one of these pieces I described in 5 seconds, but there's a lot of more detail to it, especially when you want to do it more than a simple application of just like talk to a single PDF. When you want to do it at enterprise scale, it becomes really complicated. And this leads me to one of the main themes of what we do at Vectara, which is we call RAG as a service, or RAG in a box. And essentially what we've done is we've created a platform that does all the steps I described earlier in kind of an end-to-end way. We take care of everything inside our service, and all you have to do is take your data from the source, index it using a simple API into Vectara, and then when you run a query from a user, you send a query in. Again, all the query flow gets executed here, and then you can get the response back. One thing you might be wondering is, what is this red arrow? And just to mention, a lot of kind of an emerging use case that a lot of people start thinking about is this idea of taking a response and doing something with it. So, for example, opening up a Jira ticket or sending an email to somebody. So that's what we call the action flow. So that's what's shown here. So that's how RAG works in detail. And let me kind of summarize why RAG is useful. I kind of mentioned it throughout the last few slides, but kind of at a high level, again, it augments the LM with your own data to reduce hallucinations, as I've shown. One interesting thing is that you can also get citations to improve the trust in the results, and we'll see this in the example I'm going to show in a couple of slides. So you get the response, but you also get the citations of which facts did the LLM base the response on. It's very inexpensive to implement and use because you don't need to retrain or fine tune any model. It kind of get updated right away as you add more data, pretty much instantaneously. It's private because the data, again, is not used for training the LLM, so there's no like leakage of data into the LLM that's used by an LLM vendor. You can use custom prompts to adjust the responses to different use cases. Like, let's say you want to ask the LM to generate a diagnosis or summarization, like I mentioned, of physician notes. Um, and you can also do filtering of the query flow. So there's metadata fields and things like this. So for example, you might want to ask a question about, um, give me a summarization about a patient, but only for a particular physician, right? So you can filter and get these permissioning in place, which is really important in the context of HIPAA and other regulations. Um, and again, why Vectara? I kind of mentioned it throughout, but when you build RAG on yourself, and a lot of people have done this in 2023, played around with different components, implemented this do-it-yourself flow. People find that it's more complex than it seems. The retrieval engine is more than just vector similarity, like what I've shown. There's actually a lot more detail in there that you might need to think about, and especially when you scale up and down, it becomes a problem. Cross-linguality is important to think about, and many people miss that, so more than English. You have to really have a lot of expertise in setting up all those pieces together, calling all those systems, making sure the system is up and running and has low latency, and a lot of other things that are just tough to implement when you scale up. So this is kind of part of building RAG. There's also total cost of ownership. You have to think about all the cost of calling the LLMs on your own, and that can stack up pretty quickly. And then all kinds of aspects around security, data privacy, permissioning, and data governance. One thing I want to mention that's pretty cool is we recently open sourced a model called the HHEM, which is the hallucination evaluation model. And you can find a link to it here. But this actually allows us to rank different models by the amount of times they hallucinate, or by the hallucination rate. You can see it here, and it turns out not all models are the same. And so being able to understand how much models hallucinate is very useful when you do implement RAG, because you want to make sure that you pick the best model. Okay, so I talked a lot about the technicalities of RAG. One case study I wanted to mention, this is a customer of Vectara using it for to create an ultrasound AI assistant. The company is called Sonosim. And generally what they do is they are a provider of education tools for ultrasound, and they use our product to build a chatbot, an AI assistant, to help people ask questions and learn more about the ultrasound machines that they help educate about. So check that out later on. And now I wanted to share an application that was built with Vectara. It's one of our demos applications. And what we've done here is we're going to click on this so we can see it live. So this is a demo that we created to demonstrate RAG against a custom data set. The custom data set here was a crawl of medical papers from Archive and other places. I'm sorry, from PMC, not from Archive, about rare diseases. So picked a bunch of rare diseases which are usually not getting enough attention. So that's why I like to do that here. And you can ask any question, and the response will be based on those papers and the content in these papers. So for example, I can ask, what are the main symptoms of cystic fibrosis? And what you see here is underneath this user interface, the query API for Vectara is being called. And you can see the response, the summary, which tells you about the symptoms and everything that's going on. And then you can see, as I mentioned earlier, the citations or the references. And so if you want to look further, you can click on one of these citations and go and click on this and see more information about this. One thing I want to mention is, again, you can also do this in a different language, for example, and you'll get the response in a different language. So that's, let me wait until this shows up. All right, so you get the answer in German, and we have at Vectara we support more than 100 languages, so it's really really useful. Um, so going back here, oops. So that was my demo, and then this is what I wanted to share today. Thank you for listening, and I'll take any questions right now.